What is up, guys? I hope you enjoyed that lovely music made by Carver in the last segment, because we're going to keep up with the music theme. Last segment, we learned about tension and how that affected things like frequency and wavelength, and now we're going to learn how the length of tubing affects some frequency and wavelength. Just off screen, I've got some instruments here. I have a trumpet and the lesser-known brass instrument, the mellophone. As you can see, these two have a pretty similar build, but the main difference is clearly that the mellophone is much bigger than the trumpet. So naturally, the tubing on this thing will be far bigger than on that of the trumpet. Now, I'm going to play tuning notes on both of these instruments, and we're just going to see which one has the higher pitch and therefore the higher frequency. Alright, there was the trumpet. And there was the mellophone. I used pretty much identical air and lip placement for both of them, and as you can see, the trumpet was quite a bit higher than the mellophone. That is because it has a smaller tubing, and as we know from the wavelength and speed equation, having a higher frequency means you have a shorter wavelength, and due to the shorter tubing, that is what creates the shorter wavelength that affects the pitch, which makes the trumpet higher, and the mellophone far lower. Hope you learned something from that. I'll be with you in a few minutes for diffraction.